Hello, everybody. So this starts us into Module 6, which means the end of the semester is coming up quickly. There's only 8 modules, and well, it's almost the end of April, and classes end, or the semester ends in the middle of May. So we're getting very, very close to the end. Along those lines, the progress reports were due a couple minutes ago now. Just letting me know how your final project is coming. And one thing I made in quite a few comments on those, I often comment when I grade things. So whenever you look at the grade book, make sure you look at the comments as well.
Hello.
Hi, Tyler. I'm often kind of fairly generous when I'm doing the grading, and sometimes I'll put full points on there and still write up some things in the comments about something that could have gone better, or different little things in the comments. So make sure you look at those sometimes. So I put one thing I put in a bunch of the progress reports that often gets written in progress reports is kind of addresses sort of a misunderstanding people have when they first get into programming. And that is that programming is a thinking thing. It's not a typing thing. Software developers don't make great big paychecks for sitting and typing. Jobs that are solely described as sitting there typing do not pay very much. Those are kind of low-paying jobs, but I think everybody's well aware that software development is a job that pays pretty well, and that's because it's a thinking thing. So I saw in several progress reports people saying they hadn't got much done, or weren't very far along, but then they talk about their plans and stuff, and that is progress, because most of our progress is in the thinking and planning part, and the typing and dragging our mouse around for low-code solutions, that's just tedious, busy work at the end. So if you're thinking about it, you are getting some progress done. It's not necessarily no progress if you haven't started typing Python or dragging Raptor symbols around.
I saw that you got my email.
Was that Keegan?
Yes.
Yes.
The
I have
Raptor.
contacted people on campus. It looks like the machines are turned off.
Yeah. I'm gonna
There's some
wait.
network issues in there.
Yeah, I'm gonna wait until they turn on.
Okay,
and
yeah,
then
I added your name to the list for late submissions. The computer will automatically put a late penalty on when you send it in, but I'll come back and take that penalty off.
Okay. Thank you.
I just put everybody's name on the list and then come back and override the late penalty later.
And plus, you know what? If it doesn't do it today, then at least if it comes tomorrow, and if it's on, then I know you're after school, and you could help me out with that. Since I have
I'll be
since
there
I have an
tomorrow.
algebra class, and then after my algebra class, I usually go to you, so I could get help on the Raptor if I need any help.
Okay, and also if you're at school, you can go in the lab. They're working there, but for some reason, when we replaced a network switch,
It's just that I just want to do it at home as well.
Okay.
So it's just like, that's the reason why I emailed you, is because like, if I do it in school, then there's only amount of time before my mom and dad pick me up, since I'm a full-time student here. And so like, plus I need to save that work by a certain due date. So it's important really most to do it at home.
It should be fixed soon. The lab tech is looking at it right now. I was actually going to check at the break, and hopefully he'll have it fixed by the time we take a break, about an hour from now.
But I'll just complete it as soon as the systems are online.
Okay, yes. And I think that applies to some other people as well, using MacBooks and remotely accessing the school's machines. For some reason, there's no remote access available. Actually, the only remote access we can get is to the network controls.
Thank God for KVM.
Yeah, there's only like 3 or 4 people that can access the one machine that is still accessible remotely. So it's not one of the general machines.
Yeah, it's the statewide boats.
Yeah, it should be fixed soon though.
Yep.
I will send you a message as soon as they let me know it's fixed, Keegan. So talking about progress reports, this is a thinking thing. When you're thinking about your stuff, you're making progress. It may not seem like it because you're used to the hand, having something in your hand, seeing code written on the screen. If you're doing your final project in Python, or seeing the pictures show up if you're doing it in Raptor, whichever way you chose to do it, you're used to seeing that stuff. But if you're thinking about it, that is progress. So for those who haven't turned in progress reports, if you hadn't done something because you feel like you haven't made much progress, let me know what you've been thinking about, because this is a thinking subject. The typing is just tedious, busy work at the end. Okay, so that quick announcement, then
that made me feel better. Thanks.
Yeah, once we have our thoughts in order, the code goes together quickly.
Exactly.
Writing down my progress report really helped me get my
algorithm.
thoughts together too. Like I was like, oh well, I want these enemies to have this much HP up to this and this and this. So that actually helped me put things down that would be like parameters later on.
Okay, yeah. Well, that's good to hear.
Yeah.
Before we get into today's agenda, one other note I noticed, I added here, reading through the discussion boards from this that were due a few minutes ago from the secure coding, I think was the label on it. But there was some comments about passwords, and I saw someone there, a comment along these lines, for more secure passwords, it's actually just the number of characters you use. Special characters only make it harder for a human. As far as a machine doesn't know what the letters are. So if you adding more characters makes your password more secure, and not necessarily special characters like passphrases, especially silly things that you can remember. Something like staple, cockroach, butterfly. Some nonsense words, but it makes it easy for a human to remember, because we could quickly picture a cockroach, a little roach getting stapled to a butterfly, which means we'll never forget that password, but there's a lot of letters there for the computer to try to remember. So when you have something like that, a whole bunch of random letters that fit into a nice pattern, especially if there's a picture that a human could remember. I see a reference to XKCD comics. What was it? I've seen that one a few times. The correct horse staple battery. Really, really long one. Is that the one he did in the comics? Staple
comics
battery. Somebody put a link in the chat room to this online comic thing, but something like that. That's the thing we could draw a picture with, which means we'll remember it forever, because we can put a funny little picture around those words, but it's a whole lot of characters. So special characters, that one we always see in passwords, those only make it hard for a human. So you're better off to avoid special characters or passphrases where you actually write out a sentence that is meaningful to you. It makes it a lot harder for somebody else to know what meaning you were looking for. The changing letters up and those funny patterns that we traditionally associate with passwords only make it harder for a human, because when somebody writes a program that's going to try to guess passwords, it's just going to guess random symbols, and it's going to guess every one. It doesn't know the difference between the letter F and an ampersand. Or a common one when we write passwords is replace A with the @ symbol. But the computer doesn't know what either one of those symbols means. If it's trying to guess a password, it's going to guess both of them. Or it's going to try both of them. It's like, okay, here's a symbol humans use. Maybe this is in the password. So just having more makes that more secure. Something reading through the discussion board made me decide want to add that to the notes. Funny things that you can associate with a picture are the best for human memory, which kind of segues into our first topic for today. So the basic agenda for today is having a little spiel I always like to go over in IT classes. We'll do that. It takes about 20 minutes. And then we'll get into arrays, which is one of the last big things on our major course learning objectives. The first thing I want to starting out here is something I always like to talk about in IT courses, because everybody in this class is planning on an IT career, right? I mean, sitting at a desk, working at a computer, 40 hours a week, maybe more. And sitting at a desk doing this is a really, really bad thing for the human body. We're dynamic creatures. We're at our best when we're moving. A lot of y'all probably know some senior citizens that fall into one of two categories, right? Some people retire and they go sit in a chair and watch TV, and their body just deteriorates very, very quickly. As other senior citizens are still up, constantly moving and doing stuff, and they can get up and do a lot more. And it's because they stay active. Our bodies do better when we're dynamically doing things. Yeah, so sitting at a desk, which is traditionally a flat, square, rectangular shape in an uncomfortable chair, typing on a keyboard is sort of a very bad thing to do to our bodies. So there's this concept called ergonomics. I don't want to talk about that. It's something to keep in mind if your plans are to spend the next few decades of your working careers sitting at a desk typing away on a computer. Ergonomics. The things, stuff that kind of works good. Wikipedia's had a picture for years on here that I like to point out. Okay. There's actually some problems with this picture. But this picture kind of generalizes some things. The general posture of not slouching back in the chair, which we'll talk about that, is a very old picture, as you can tell from the hairstyle and clothes style. But the angle of looking at the computer, you want to try to look straight at your monitor, not looking down constantly, or be in a position where you have to tilt your head back, because try to have your neck in like a natural posture so the strain doesn't wear on it. This picture also has a problem with the arms, and that's not a very good thing. The keyboard looks like, we'll talk about keyboards first, but that picture seems like a good starting point, because it's an old picture, so there are some things wrong with that picture and a couple of good things about it, but it's not the natural form for the human body is a big part of the problem with it. So I guess we'll start here with keyboards, right? That's where we're going to do a lot of things working on keyboards, which I apparently don't have any keyboards around, so I had to grab one of the laptops, but y'all know what a keyboard looks like.
Are we talking about ergonomics today?
About 10 minutes, 15 minutes, just a couple. I always like to cover this somewhere.
Okay.
And then we're going to get into some, then we'll get back to the other stuff. Actually, the whole second half after the break is going to be examples. So yeah, that's why I always try to squeeze this in somewhere, because everybody here is planning on a working career. Like typing away on a keyboard, there are a couple things to keep in mind. One of the first ones is how you press the keys. You can think of it, like if anybody had like piano lessons, you don't want to like swipe your fingers down. It's a lot better. You want to have some sort of position where you're pushing straight down and like bending from the knuckle more so than one of the middle pieces. That can make a difference. But where I'm holding my arm here, that can cause a big problem, right? The keyboard's flat. That's the reason I really wanted to grab it. It's flat, very unnatural surface. And usually if that's sitting on our desk, we're just, our arms rested on it. And you'll notice that my hand has to go up in order to get into that position where I can type down. It's much, much better to have your arm elevated. They make little things to raise it up. That helps a little. One of the biggest issues going into IT is, you've probably heard of it, thing called carpal tunnel. It's actually the tube in your arm that all the nerves from your hand go through. And if that tube gets damaged, which laying flat typing on a keyboard will damage that just from usage. My understanding is when that tube gets damaged, your brain constantly gets a pain signal from your hand. So it's just like your hands always hurt, is what they say it is.
Not a disease, but it's called Duplicanes Contracture, also known as Duplicanes disease, is an abnormal thickening of the skin in the palm of your hand at the base of your fingers. And that could be a problem too when it comes to typing and everything. So
Yeah,
it's just not only carpal tunnel, but you could get that disease from being at a computer too much, and then your finger just sticks. You know,
some of the things like
doesn't move
that,
at all.
there's little things we can do to help avoid it.
Exactly, like doing finger exercises, like just like, you know, not cracking bones a lot, but you could just like just do this.
Not just that. That's what I was getting ready
Training your
to get into
forearms
here,
really
Keegan.
helps.
Some good things. There's better things we can do. Little exercises help. I mentioned that lifting your arm up can help delay carpal tunnel. We can't put it off indefinitely. But the biggest problem, actually I'll show here. The biggest problem is the keyboard's flat. We hold our fingers like that.
Like a zombie, like we do.
When I do this position, so yeah, Hollywood always does that as zombies, but zombies wouldn't walk like that because I have to force my hands into this position. If I relax, my hands do this.
Exactly, but it's like, you know, the same thing, zombie. So you don't want to be zombie, like you want to keep your hands moving. You want to keep your hands active.
Oh, actually, that is what we want to, that's how we want to type. So that's the first thing I was going to look at here. The equipment we use can make a big difference. So like ergonomic keyboards. We can look at some pictures. So they have better shapes of keyboards that instead of doing that flat thing where we have to force our hand in that position, we're in the relaxed position, what a zombie would really be like, where if we just hold out our hands, they try to go inward. Yes, something to lift your arm up and even lift it up, which the natural position is not flat. So I guess you can kind of see it in this picture. So keyboards that like bow up in the middle, so that we're typing like this.
By the way, what are some good techniques for, you know, posturing? So just like, you know.
Oh, we're gonna get to that in a second, Keegan.
Okay.
This was just about a 20 minute spiel I like to go through. So I was going to cover a few things, and one of those being the best posture for us.
Yeah.
It relates to this too, but notice that it's a more natural posture. Even better, right? Well, like Keegan pointed out, the zombie thing, that having both of our arms in the same spot is kind of unnatural as well. So we have the split keyboards. Which
but I mean, like, unlike a zombie, zombies don't get their fingers are not active. Humans are. So keep your fingers active and keep it active.
Or something like this. Notice how that looks a lot more like the shape of a hand, or that keyboard down there. They're very natural. It fits the natural shape. We don't have to manipulate our body into the unnatural rectangular shape. Something that fits us better. There's even some, you can see there's lots and lots of different shapes. So it's something to keep in mind if you're planning on spending a full-time working career sitting at a desk. Put some money into a good keyboard to help alleviate some of the stresses on your body. There's some like this that are adjustable, so you can fit it perfectly to where your body what your body naturally wants to do.
The mechanical ergonomic keyboards are where your money, it's a money hole.
Oh, there's some other ones here. It's usually near the top.
You can build your own keyboards too if you're ever interested in that. It's really cool.
Oh yeah, they're you can build them. One of my favorite little hobbies or pastimes is to make or try to invent new input devices.
Oh,
It's a lot of fun. Some of them work better than others. Well, I don't see the picture I was looking for, and it's usually near the top. Yeah, so the split ones are really nice. And when we get up to the, like he can ask about posture, there'll be a nice one there.
Do you have a preference?
I just use regular keyboards, but just the one piece that just bows up a little. That way we don't have to really learn to retype. Because the one I was looking for, maybe if I do this, that it's very similar. Okay, here we go. It'll probably be on here. Yeah, this one right here. I was kind of looking for a particular one that usually shows up with the pictures of ergonomic keyboards, but that round shape. I might have to scroll for a while to find a picture of it, apparently. These are really nice too, where that curved bottom, those are actually very comfortable if you spend a long time at a keyboard. You can see there's lots and lots of shapes. There's one that's going to look really, really strange whenever I find the picture of it here, which is usually near the top, but I might have to go to the other search and point at one of the ones that's more for like used in like music. That one kind of is, but those are really nice. Those when we see the final version where it's split keyboard fitting that natural curved shape of your hand, those can make a big difference. I just went all the way to the bottom and did not see the picture I was looking for. What's up here? I think this is going to have like specialty ones. We can kind of see it in this picture. I'll just look at this picture. This isn't the exact one I was looking for, but you see that circular shape? It looks really strange. We'd have to completely learn to retype on that. But there are some, that shape wasn't
What is
designed
going
by
on?
engineers.
What is this radial
is it like a stenographer's
Computer-
keyboard kind of thing?
keyboard design?
Music producers have really taken to those, so they've kind of customized those to fit music
What
producers
is
more.
what
But
is
the thing is, those the original ones maybe if I do radial ergonomic keyboard. Those were not designed by engineers. Those, well, there's that same picture again. Those were designed by podiatrists. Is that the right word? The hand doctors. So that keyboard, that shape of keyboard is what the world's leading experts on the human hand said is the perfect shape for us to type with. So when you add some of those other features in, if you obviously you'd have to completely learn to retype with that. I don't see any pictures of the original one. I was wanting to point at the original one because it doesn't look as far off as the latest versions. We'd have to learn to retype with that, but that shape, that wasn't engineers sitting down thinking about the way typewriters were laid out, or just a way to get all the buttons into that space. That was the shape that hand doctors, experts in the human hand, put together and said that's the best shape for humans to type with. And if you stare at it for a minute, you should see how that looks. Your fingers naturally fall into that pattern right there. So something to consider if you're in this class, you're planning on an IT career, so that can make a big difference. The next one to look at is this thing right here. This is one of the big problems for, well, you'll notice that as I hold it here, I can't even hold it in the using position. To hold it with one hand is different than how I would use this device. It's just a big square box thing. And there's actually a story behind that square boxy shape on those. Has anybody ever seen a picture of the original mouse?
No, I don't think I've seen the original yet.
It's in the Smithsonian.
Oh, the Smithsonian, right?
Yeah, so it goes around a little. But here, yeah, here it is. So the engineer had the idea. He had all the components, and he just had this wooden box sitting on his desk. And, it was probably, you can tell it was cut out of a 2x4 or something, so it was probably holding paper clips on his desk. And he just grabbed it and put the stuff in there. So he just grabbed a random box and it's like, okay, this will hold the components. Stuck them in there and it worked. And it's never really changed. That was 1967, I think, late 60s. So here we are coming on, approaching 60 years later, and we still haven't really, most of us still use that box shape, which is very, very unnatural, right? It's not, it doesn't fit the natural shape of our hand, or like I was doing a second ago, if you hold one, you can't hold one in the using position with just one hand, which isn't really a problem because the device itself sits on a table, so we don't need to hold it. We just have to move it. But again, there are some improvements. One of the best ones for our hand, I was just going to jump ahead to one of the best ones for our hand, is the vertical mouse. You'll notice in those pictures, that's when I held my hand out. So like, here's the mouse position, right? Kind of have to force my hand in this position. But again, if I relax, there's the relaxed position of my hand. And you can see on the pictures there that they're set up to just go with them. Oh, somebody put in the chat room, it was 1968 when that was made. Yeah, it's in the Smithsonian, but it's one of the things from the Smithsonian that tours around museums all over the country, because that's a mouse.
By the way,
that's a big deal in our modern world.
Yeah, it's not in
So-
viewing right now,
So in
but
the
I did see it in the
Smithsonian,
American History Museum in 2014. I want to say.
Yeah. I mean, that's one of the main tools everybody uses in our modern world. So that one's just constantly on tour. It belongs to the Smithsonian though.
so it belongs to Smithsonian, the original, but is there like replicas that you could Are they replicas
They
on the
might have a
market?
replica there. That's probably what it was.
Is there replicas that you can get? And
Oh, yeah.
Yeah.
That's lots
In
and lots
American
of
History
people have
Museum.
made those. You probably find the designs online. It's just two wheels and the trigger potentiometers.
right.
Oh, that'd be a nifty little
Project.
knickknack to have. Yeah.
Yo, I would like to have one of those.
Yeah, it's really not complicated. You could probably make your own. It'd be kind of fun to make your own. But as far as our thing
That'd be a good
here,
project.
you can see the vertical mouse is the one that follows our position. It still moves around like a mouse. Our hand sits in that relaxed position. There's some other ones like this, where you, instead of moving it, you have the trackball. I was going to talk about trackball stuff here in a moment, because those are pretty nice too.
That was my first gaming mouse, like, well, my stepdad's, but that's the first one I used to game on a computer.
It makes a big
Played
difference.
Quake with it. Yes, it would.
You don't get
master.
you don't get ham cramps if you spend a long time doing stuff. There's also trackball mouses. Those are usually, well, I see a lot of vertical mouses. Oh, there's a trackball. Yeah. So here the mouse is stationary. It doesn't move, and then your thumb just rolls the ball around. We can get a lot more control over that. And the human thumb is one of those, our thumb and our hips, our muscles will never get exhausted on those two things. Our bones will wear out. Our bones will wear out on, well, it happens a lot on the hips, but your muscles on your thumb and your hip will never get exhausted. You do this forever. And there's only a couple spots in our bodies that particular our body is set up so that particular muscle never gets tired. So if the mouse stays still and you're just moving your thumb around, your arm's in a resting position the whole time, you get really good control. Designers like those. I've seen a lot of designers have a big preference for those. I've never used the triangle one. That doesn't necessarily look comfortable, but I see how it evolves.
It's about the cones.
Yeah. Yeah. Just a little adjustment on the vertical thing. Maybe it fits different people's hands. You can find a cone that's just the right size for your hand. But those things are better than just a generic mouse or a flat keyboard. They'll help with your body. And if you're in this class, you're planning on spending a lot of time at a desk using a mouse and a keyboard, which is kind of the last thing I wanted to look at. Basically, just keep these things in mind, that if you're gonna, but the traditional saying is, have the right tools for the right job. If this is going to be your job, go ahead and look into the best tools for doing this job. The ones that won't give you carpal tunnel or aggravate carpal tunnel, because we're doing stuff with our fingers. So we're eventually going to wear out that nerve, that tube holding the nerves. And then we get carpal tunnel syndrome, which my understanding of that is your brain just always receives a pain signal from your hand, which sounds unpleasant. Last one I wanted to look at, well, along with the desk, right? Big square rectangles, that's not a natural shape. That's not something that really shows up much in the natural world anywhere. So that can't be the shape that our body works best with. Does anybody know what the best position for working actually is? Well, standing desk are very good, but not, there's something even better than standing desk. Which is another one.
Standing chair?
I think, what was that, Tyler?
Like a standing chair?
Well, standing chairs are
Like those little stool things?
That's a more natural posture, but the best one is what's called a zero gravity. Really zero gravity. There's something I've seen in car commercials, they say has zero gravity chairs in their cars, but zero gravity is this position. So I don't know what they're referring to in cars, because you definitely couldn't drive a car like that.
Anything that separates you from the ground is always worth the investment.
Yeah, she looks like she's asleep. Oh, there it is right there. Just a little stand on the couch. you've probably seen lots and lots of pictures of kids with like tablets and things that just go into that posture. You've probably sat there yourself. If we're holding our phone there, that kind of negates some of it. But these workstations down here. So this is actually the best posture to do desk work at. Really, and these are really expensive. They make cheaper options. Well, like the little stand for a couch or some of the chairs. And remember, if it's a business expense, it's a write-off on your taxes, and tax write-offs are nice when you're making 6 figures a year. These are really expensive. They make cheaper versions, but they look really awesome. If you had something like this with those split ergonomic keyboards, so you're just laid back, your hands in a comfortable position, it makes a difference on your body. Some of these get really expensive. These Scorpion ones here, those are fully automated. It looks like a regular chair, and then when you sit down, all of that stuff comes out and the chair rolls backwards. Those are really, really expensive. Those are like buying a house. But they make some cheaper versions. That one doesn't look as expensive as some. Or things that come in different spots. There's like a chair and things sitting above it. That's actually the best position to do this kind of work for. So if you're going to do a lot of it, maybe not those, might need to roll down to some of the cheaper ones, like the $400 chair, which keep in mind, those are professional models sitting in that chair. So the first time you're in a chair that leans back that far, you're probably going to experience a little bit of anxiety, a bit of a panic from definitely going to feel like falling, which is why they call them zero gravity things. But it gives us better positions. Or this one where you sit here and your knees go here. So you're like in yeah, that it's hard to picture that without somebody sitting there. I guess I could draw a stick man. So you're like up here working and your knees go to the pads. So it's like you're kneeling down and leaning forward, which is again a very natural position for you.
I definitely need one of these for my back.
Yeah, the natural position. So yeah, kind of like this when you're Johnny put in the chat room, like a fetal form. You're working in that curled up in that fetal position, which is obviously one of our most natural positions. So it's it doesn't damage our body like sitting at a desk does. Make a lot of cool things. So that's the best one. Those obviously get very expensive, especially when you get into things like the Scorpion workstations. Those fold up into a little chair and it's just automated. So that when you sit down, all of that other stuff comes out. Looks really, really neat. You can find some videos of the good ones. But something to keep in mind, since everybody in this class is going into IT field, having the right tool for the job, and it's probably worth your time to look into getting a really nice keyboard and a mouse, at least. Right? At least maybe not those very, very expensive workstations, but a nice vertical mouse and a good ergonomic keyboard. You fit those in your backpack and use those on your way through school and everything, and it'll be much, much better for your body. Right? I mentioned senior citizens earlier. Some of y'all may have seen this. Some people retire from a career in the construction industry, and others retire from a desk job. And frankly, the person that spent their working career doing construction is a lot better off than the person that spent their working career at a desk because of that mobility. Obviously, there's a lot more little injuries that happen to that person along the way in construction than the desk. But they were moving and dynamic the whole time. So their body didn't get that old person lockup from it. their body just didn't just stop working because they spent too many decades at a desk. Something to keep in mind. I always like to mention that somewhere in the IT classes. And yeah, today seemed like a good day to fit that spiel in. And the vertical mouse and ergonomic keyboards, the price on those starts equivalent to what a regular mouse and regular keyboard would cost. So definitely worth looking into. Something to keep in mind. Okay, so does anybody have any questions before we get into our next topic here? Okay, I assume the silence means no questions. So our next thing to look at is arrays. And we're going to use this word over and over again as we talk about stuff. But because of the technicality, I'm going to throw the word list in here as well. And we'll get to that technicality here in just a moment. And the reason we always use this one, we just use this word when we're speaking, but we'll see the definitions on both of them here shortly. So we started this course with variables, right? Our very first example, that introduction discussion board, I had you save some data points about yourself, like your name, your age, the town you live in, just a few things into variables, a single data point stuck in memory, and humans will never remember memory locations. So we give the spots in memory we're using reference names. So we give a name to a spot in memory and stick a single data point in there. That's a variable. Just a single value. And then we extended that last week when we were talking about functions and saw that a named location in memory, well, we could also store a set of instructions there. And I think when I was putting these notes together, I realized I think we kind of skipped over that the other day. So I'm going to pull something up, just a quick example. I'm on my PC, so I'm going to hit Windows X, get all the control features. I like to show keyboard shortcuts. The Windows key is really useful if you're not used to it, because well, with keyboard, we have like 100, usually over 100 buttons, and a mouse, we only have 2 to 6 buttons. So obviously we have a lot more control with that 100 buttons than we do with the 2 buttons. So you want to learn those. Like Windows E as an Explorer will open up your thing there, or Control W works to close any window. To get to your control features functions on a Windows machine, if you push that Windows key and X, just Windows, then the letter X, you'll get the shortcuts to all of your control options for the operating system. One of those being down here, the Windows terminal. So you can click on it there, or keyboard shortcuts. If you do Windows X to get that list, then you see I is underlined on the second one above the list down there. So the Windows terminal, which they've updated the version for Windows 11. The new one in Windows 11 is nice when you go in that way. You got a PowerShell, but you can switch to command prompt or just go right to a command line on Azure, have cloud things and access any server right from it. So that's a nice, really nice update on Windows 11. Then PowerShell is one of the 2 ways we have to do our operating system control language. I was actually going to look at this one next week because now we've seen all the parts from a programming language. So I like to always come back after we've seen all those parts, right, stretched out, and we spend like a week on each one. And we'll do about 45 minutes. We'll see all of it in PowerShell to kind of go over how, now that we've studied the parts in depth, all we need to see is the syntax for a new one to learn a new language. But I was just going to show something in Python. So I'll jump over to the Python interpreter here. And we saw functions last week where we store sets of instructions, have a keyword define, and I'll just do something like call it say hi. pass in a parameter, I'll say times, and then that's just print the word hello world, and then times is how many times to print it. So while times is bigger than 0, we'll print hello world, our standard configuration check. And then we don't want to do that forever. So then take times and decrement times by 1 each time, so that it eventually gets down to 0 and ends the loop. We might not have seen what I did there. I can't go back in the place I'm typing. So times minus equals 1 is the same thing as times equals times minus 1. So that happens so often, we have a shortcut in pretty much all of our languages. Same thing with plus. I guess I could write it here. So like times equals times plus 1. We have a shortcut that times plus equals 1 is an equivalent statement. Once it gets to machine language, it's exactly the same. But that happens so often, we have a shortcut in pretty much all of our programming languages for that. So we'll decrement the number by 1 and just print that out a few times. So we saw functions. It's like we have with variables. Instead of storing a single data point, we stored a set of instructions. So then we can call that, or this is what I realized we didn't actually look at. If we just say the name for it, if we just say the name, it tells us we have a function stored at this spot in memory. Okay? And as humans, we would never remember this part. That's what our reference names are for. Because we would never remember to type 0x0001C9515E3E20 every time we need to recall that function. So alternatively, we put a useful name on it, and then we can just ask for it. And well, I'm in Python, so to call it, we use parentheses. So we use that reference name, and then parentheses are kind of our standard symbol to do something. I'll just put in like a 7. So it'll print out that message. It'll run those instructions and print out that message 7 times. So an expansion on variables that would hold just a single point of data, we can store a collection of stuff. So the next extension up from that, instead of one single data point, it can be useful to store a bunch of data points to one reference name. Store a whole bunch of data, and then we only need one word to retrieve all of that data. Instead of having to, if we have 50 data points we need to store, instead of coming up with 50 different variable names, it'd be nice to have a collection where we could put all 50 points to the same reference name and kind of organize our code that way. And just like we saw with functions, when we were talking about that, we kept, I don't know why I stood up. My notes right here say there's another example to do there on the same console. I don't know why I closed it and stood up. Just like we saw with functions, we've been using some of them since day 1, right? Those pre-built things that we just ask for, and they're already ready for us to go. What we extended was we added our own. So we've actually been doing the collection of things since day 1. Is a string where we put our written language, wrap things in quotation marks because we want all those letters to always go together. We want all those characters to always go together. A string is an array of characters. So just as we preview this, I'll go back in here, Windows. I'll go back to this terminal again. Back into Python, though we'll look at these concepts we've been studying in PowerShell before long. So has some advantages. The old command prompts, the Unix terminal instructions, and the DOS commands that Windows was built off of. Those were written back in the 1970s for the most part, some of them in the early 80s. But back then, RAM was a very precious commodity, and we certainly didn't want to waste RAM on computer experts. So things like the programming languages were all abbreviated, and we had to come up with abbreviations and shortcuts. But by 2003 or so, that definitely wasn't the case. And Windows was the first one to update theirs. That's what they invented PowerShell, by redoing all those old abbreviated commands with things that are fully spelled out. So then we don't have to remember two parts. We don't have to remember what it is and how to abbreviate it. We just have to remember what we want to do. Think about what we want to do, and then it's a spelled out version. But we're going to look at that soon. Now, for now, jumping back into Python and some of the things we've seen, like I'll use name. That's a good one. We've seen strings. Take the letters that spell out my name. I'll add some more. And store that in a variable so that we could ask for it again. And print that out and see that there. But each one of those characters spelling out my name there is its own data point, right? That's, we talked about ASCII code and Unicode. So C is 65, 66 is B. So that's ASCII code 67. H 97, 98, 99. 101, 102, or 103. So each one of those is a single data point. Do you have a question, Keegan?
Yeah, and so like one of these questions, like, you know, or not questions, but points is like, once like you make a data point, like it's in the database forever, right?
Not necessarily forever. We can take them out. We can delete stuff from a database.
Yeah, but I mean, like, I meant to ask, like, is it like, you know, it's there. So once you put it in, like, you know.
Oh, once we create a variable?
Yeah, once you create a variable.
It is there until the program finishes.
Yep.
I have another question, Chris. Can I use Atom to program in Python? I'm looking up a package for it, the IDE-Python package. Because I'm on Windows 10 in my VM and it doesn't have that PowerShell. It's trying to install Python with Windows Store.
You would need an environment variable. I'll show you how to set that up. I'll show how to set that up after our lecture today, if anybody wants to run Python in this.
For sure. Yeah. And any idea for if you have,
do you have Python installed?
I'm sure I probably don't. Unless it came with Linux Mint, I don't.
Okay, so I should do something where y'all can run this. Normally
I can't do cloud-based because I have terrible internet. I tried the Ripple. It was not working for me, but it's a great option. It really is.
In your bash shell, Python was used to build bash. So if you just type Python in bash, you'll get Python 2.7.
Oh, okay.
Yeah.
That's what I was.
You're a Linux user. Same thing for Mac users. If you open your terminal and type Python, this little bit that I'm showing here, you could do right there.
Let me do this.
It's an old version of Python that really needs to be updated.
Can I update it? Well, yeah, of course I can. But
Python, the Unix shell was actually built. Something in there was actually built using Python. Okay. So
I do have Python.
Yeah, it was just this was just a really quick way to show a couple things about Python.
Oh, for sure. I just like to follow along.
Okay.
Continue. I found it. I have Python 3 on Linux, and it actually came prepackaged with that. Just
yeah.
Pretty interesting.
Yeah, you're on Mint. It's gonna Python. There'll be different ones.
Yeah. You gotta love the distros.
We saw stored in strings, but each one of those, I just counted out the ASCII code. Each character is its own data point. So name is actually an entire collection of characters. So in Python, if we ask for the length of something, which is a pre-built function, abbreviated LEN, because it was made back in those days where we didn't want to waste RAM on computer experts. So the programming languages were all abbreviated. If I ask for the length of name, See, there's 11 data points in there, spelling out Christopher. And further, we can access each one individually. I'm gonna use square brackets this time. So if I ask for 4, I get an S, which if we count 1, 2, 3, 4, 5, that's the 5th letter. Is we start at 0, which I'm going to talk about why we start at 0 here shortly. But we can access each one of those letters in that string individually. Name the 7, which would be the 8th letter, brings back a P. So strings, which we've been working from since day 1, aren't actually a single data point. That is already a collection of data points. So it's not really a new thing that we're doing here today. Did you have another question, Keegan? Your hand's up, or is that up?
Sorry, I keep forgetting to not put it away.
Okay, sometimes I don't notice those. Just speak up if you have a question. There's no such thing as an interruption in a Zoom call. I don't always notice the hands. So that gets us into our stuff for today. Arrays and lists. So I have a note here. You probably noticed that we cover a wide assortment of things in this class, right? A huge assortment of stuff in this course. And this is the intro level. So we're really looking for exposure at this point. There's a bunch of stuff because we want to expose you to everything, and then you're working the fine details later as you come back and see them again and again. And repetition is an important aspect in learning, and part of the reason college stretches out over many, many semesters. So you hear about the part and fill in the details as you progress further. But a lot of these things that we've seen, it's very obvious why we're doing what we're doing, the usefulness of it. Today's topics, it doesn't fall in that category. It's kind of hard to see how this is better at the introduction level. For one, most of our examples are going to be right about the same amount of code as if we would have used a bunch of separate variables because of how we're going to introduce it. But it's not just this class, right? So here in our class and coding boot camps, online tutorials, wherever you're learning about these, that's always the case with arrays and lists. It's really hard to see the usefulness of it immediately at the introduction level. The actual usefulness of it comes later. So I like to start with an analogy. So for example, listeners can relate to heading to school for a day, right? Everybody knows about that situation. So there's stuff we're going to need when we go to school. So I got a bunch of props here for today's stuff. So like you're gonna need a book, heading out of campus, need a book. I just grabbed the book for tonight's game development class. That was actually already sitting in here. A couple notebooks. That's some notebooks, might need those. A soda to avoid paying $1.75 or $2 or whatever the vending machine charges these days. Couple folders, might need some stuff out of that. What else we got here? Calculator, be important to have a calculator with us. Oops, there goes the calculator. Pen and pencils, pack of chewing gum, pick the calculator back up, and got a big pile of stuff. Maybe it'll stop falling if I move that soda up to the top instead of the middle. It's kind of shuffling around, but eventually there we go. Got a pile of stuff for the day, and I can go to school, carry this around all day, set it on the table while in class, and pick it back up, carry it around. That gets through the day, right? But there's a better way. Also have this thing. Right? I think everybody knows what a backpack is. So a much better option than just carrying this big pile of stuff is to stick it into this backpack here. Stick the soda in there, the calculator, pens, pencils, the folders. Oh, whoops, that's probably the wrong pocket. Use the bigger pocket. So I don't run out of room in there. I can take all this stuff, stick it right here in the backpack. The notebooks and the book, and then just throw this on my back, and carrying it around works a lot better. It's already been like 5 seconds and I haven't dropped anything yet for one. A much better way to carry things. So that's akin to what we've been doing, right? That big pile of stuff. We had a whole bunch of individual items separate. So that's kind of what variables are. And the backpack's more like a list. It's now can easily carry everything around. And when I need to get something, so say, okay, I need the calculator to accentuate the process, analyze the process of getting something out of the backpack. We've done before. Go over to the backpack, look at the first item. Is this the calculator? Nope, that's not what I need. Grab look at the next one. Is this the calculator? Nope, that's not what I need. Is this the calculator? Nope. And keep going through there. Is this the calculator? Oh, there it is. And keep going through and just asking, is this the thing I need? Oh, and when we find it, set that aside. So what else? The calculator, probably need one of the notebooks. Is this a notebook? Well, it's a bunch of paper, but not a notebook. Is this a notebook for writing in? Yeah, that'll work. And that's the process. Every time we need something from one of those items, we just go through everything in there and check them one at a time to see if it's the one we're looking for. Hopefully that analogy makes sense. And that's where the usefulness of arrays comes in. Is frankly, when we get to examples, which is going to come very, very quickly after break. There's one, just a little bit of talking, and then in the rest of the day we'll go to breaks, and then half of these notes are for picking up and expanding it on Monday. But when we get there, and then in the homework for this week, a lot of times it's going to seem like it takes more code to put the array together, and it would have been shorter to do with variables. And that just comes along with the introduction level. But even the times when it is about the same amount of code, because we're not going to, I don't think any of our examples at this level are going to actually make it shorter. It's hard to see the advantages. So that's why I like to start with that analogy, because with a pile of books and pens and sodas versus putting everything in a backpack, I think everybody's already familiar with the advantage there. We work with a collection of items, the backpack stuffed full of stuff, as opposed to a bunch of single individual items. So the advantage this gives us when coding in the long run, once we get past the introduction level, is analogous to that. So an array, our definition on array. I haven't been using that in this class. I'm using an asterisk every time I write a definition in this class. So for an array, is an ordered collection of like type data stored via recursive algorithm. So kind of a lot of words there. An ordered collection of like type data stored in memory locations via a recursive algorithm. Oh, I left off the section off. Stored in memory locations that's important because we're in RAM, our current working thing, part of the CPU, not in long-term storage, stored in memory locations via recursive algorithm. And we saw recursion, kind of know what that means. That means we're going to do the same thing over and over and over again. So for a
So it's
picture
just
on
another
this,
loop.
not quite the same as a loop.
Not the same? Okay.
A loop is a simplification. A recursion just means repetitive. Loop is a very special case. Remember, loop, just on the technical term for the words, a loop is a simplification. It's a modification of a selection structure. Whereas recursion is repeating the same math formula. So if our algorithm is we have some sort of start point, then our next one, I'll draw that on the picture, and I'll talk about the difference between recursion and looping, how this would be different than a loop. So we've seen these types of diagrams, stack heap diagrams where our stack represents our code. So we'll say we have an array, an ordered collection of like type data. And then that's going to refer to some spots over in memory first. Second, I'll just write them as 1, 2, and 3. And third. And it just kind of points, our reference points at those spots in memory, which have a start point. And each one has an endpoint. And that picture, I ran out of room, but it's like type data, so they would all be the same size. So maybe each one is 8 bits. Let's go with each one's one single byte. So our first is 8 bits, our second is 8 bits, and our third is 8 bits of data. So some simple integers there. And a recursive algorithm means we're going to use the same math formula to put there over and over and over again. So maybe we have something like, I'll just do a little simple line. I think math fast, like 3x plus 16 will give us a line. And maybe x is our replace x with the size of our data, and all of that adds to the starting point to find where our next one is. And the difference for the recursion one and a loop is we have to modify a bunch of things. We need to keep track of extra things. But with recursion, we just go right into the formula. So instead of maybe start here, the current one we're looking at, where that starts, and then we'll calculate where the next one is. And then that value there goes right back into the formula. We don't have to have any extra higher level modifications above it. Does that make sense, Tyler?
Oh, I'm starting to understand. So kind of like a more efficient way to do that Raptor project that we did. My
Yes.
internet's kind of bad right now.
Yeah,
but
so a loop is specifically in programming. We'd set up a selection structure, we'd check our condition. Then we'd set up a bunch of modifications and check that condition again and check that condition again. But Heap with recursion,
it just automatically does it. It does the
we
calculation.
do this equation, and
Okay.
the output of this equation is the input of the next equation.
Ah, okay.
So we don't have any extra stuff. Output goes right back to input.
I understand. It doesn't have any other extra checks to make. It goes, it's continuous.
Yes. So a subtle difference, but we're in the situation where we need to focus on those technicalities and subtle differences.
Makes sense.
Make sure make sure our vocabulary is all being used correctly. So maybe that's our size. So let's say our start bit is 100. The computer stuck that at bit number 100. And that's why we start at 0, because our data starts at bit 100 plus 0. Right, so the computer's going to remember it starts at bit number 100. And so it goes there, plus 1 plus 0 is the beginning of our first data thing. Then 100. The current one starts at 100, so we plug that in there. We have 8-bit data, so 3 times 8 is 24, plus 16 would get us up to 40. So 100 plus 40 gets us to the end of our thing, the 8 bits. So we get 140, so then that goes right back in, and that's where our next one starts. 140 plus, again, it's given a size of 40. Give it a little bit of buffer space and stuff. Would take us up to 180. So that comes right back in, and that's where our third one starts. So we have 40, basically 40 for each one. So our start point plus 0 gets us to the first element. Our start point plus 40 gets us to the second element. So plus 1 times 40 gets us to the second element. Our start point plus 2 times 40 gets us to the bit number 180 where the third element starts. And we use that same pattern over and over and over again. So that's what.
How do we define when it stops?
We have to define how big it is to begin with.
Okay.
That's a restriction on an array, is we have to say, okay, when we initially create it, we have to tell the computer, okay, we're going to store, our term is elements. So each one of our things becomes an element in the array. We have to immediately say, we're going to store 3 elements, or we're going to store 12 elements. If we say we're going to store 3 elements,
Those math equations
later, we have a
are
fourth
the
element.
elements.
We can't change our array. We have to make a new array that we said is going to hold 4 elements, and then copy these 3 things over to the new one and add the 4th one in. So it's non-dynamic. We can't change it. There's some keywords here.
Very static.
Yes. Oh, it hasn't shown up yet. Static is a critical word for this stuff. It's not going to show up in this class, but static means there's one and only one copy. That's an important one in IT stuff, because sometimes we'll end up with lots of copies, right? If we have lots of data, right? Maybe we have a big, huge program running and the number 3 has shown up like 20 times in that program. We'll have 20 copies of the number 3, which is kind of wasteful. It'd be much better if we had one and only one copy of the number 3, and then just use that every time, reference that every time we needed it. So that's a vocab term that it doesn't really show up in our class, but we might as well pause and mention it's on the list of specific terminology. Static in computers means one and only one copy. But yes, for normal English usage of static, it's non-dynamic. It does not change. And since static such an important word as far as IT vocabulary, we would normally say non-dynamic.
Okay,
Doesn't come out the best for English because that word sometimes
that makes sense
blows
though.
up.
It's not static, it's non-dynamic.
Yeah, that's such an important.
Because it's not only
concept.
one.
We went ahead and made a very specific usage for that common English word. So then when we actually need that, what we would call static in English, we have to go the longer non-dynamic version. But we cannot change it. And there's another thing here. Notice that it's like type of data. Our algorithm was very important that we used the size of the data. Which, by the way, this was just an example. In the modern world, our algorithm is pretty much always +1 plus size. Way back in the day when this definition was created, our RAM actually was composed of heating coils and heating up little coils of wire so they would expand and move mercury around and turn the switch on and off. But there was actually heating coils all over RAM. So 64 bits meant you had
Like
64
old
heating
thermostats.
coils. So if you had, the same bimetallic strips, so that when we heat them up, they bend differently. And we can control that.
Those things are fascinating. I love those things.
Yeah, it's two types of metal. So usually cheap metals, because we don't want to spend a fortune on it. But like say we have nickel and copper, and we press them together, braze them together or weld them, depending on the types of metal. Somehow we attach them into a single piece. And when we heat them up, they don't expand and contract the same way. So that they bend. When we heat them up and cool them down, maybe the nickel, the copper stretches more than the nickel, which makes it bend.
Oh, like those metal spirals.
Yes. And then when we have a long one, we curl it up in a spring and we get very precise control over it. So it's just two types of metal, but that was our early computers. We actually used heating coils there. So if we had 64 bits of RAM, that meant we had 64 heating coils in a really, really small space. So if we would have turned on heating coil, so we really didn't want to turn on the heating coils right next to each other any more than we would have to, because that becomes a fire risk pretty quick, right? If you turn on 64 heating coils right next to each other, there's a pretty good chance of a fire, something's going to catch on fire. So we'd want to spread those out. But now in the days of silicon, it's not a fire risk. So we just use the easy algorithm of +1, but that size is still important. It's +1 of the size. It's just that if it's 8 bits, it's the next 8 bits over. Which means we can't be mixing our data types. But both languages we're working in here this semester, the flowcharts stuff is built on Perl, which is an open type language. So by extension, Raptor is open typed, and Python is an open type language. So we don't have like type of data. That's not something we can work with in either one. So technically, we do not have arrays in anything we're going to see this semester. We have list, but we're going to use the word array because that's a common usage. Well, we're just, that's why I'm focused on vocabulary today, because sometimes the way we use terms isn't necessarily the actual meaning of them, right? For example, we say Google, when go Google that instead of search for that. And Google's the name of one particular search engine. Or we say TiVo instead of digital video recorder. And like a name brand one took the places of the noun we use. So we typically speak of arrays the same way because all of our other things where we have collections of data are like list. They show up in common English, and we don't want to add an extra layer of confusion there on whether we're talking about the English version or the very programmatic specific one. So we just use arrays as our generic term, the same way we say use Google when we mean search for something or use a search engine. So we're mostly going to talk about list, which is another picture for the board, and then some examples, but it's probably a good time to take a break, right? Been over an hour. So one more definition and picture for the board, and then the whole rest of the class is examples of doing stuff with this. But we've already been at this for over an hour, so just 10 minutes sound good?
Yeah.
Sounds good to me.
All right, so it's 2:21. We'll get back to it at 2:31. I'm gonna go grab some coffee. I will see you all in a moment.